two numbers, and we said one of the ways, keep going and you'll get it. No, because then you'll tear that one out and you'll lose it, and then you'll get going.
Bad stuff
Is he hurting
Who
your
was?
head?
He was?
Is he hurting your head this day?
Yeah. All right, so remember, a ratio is simply a fraction. That's one way of saying it. So again, you can't look up here today because it's broke. So, real simple version, we would say A over B is equal to C over D. Okay? And so, again, where A, B, C, and D are just any kind of number. All right, so the first part, we're going to say, do the two ratios make a proportion? So you have two different ways of deciding this. Number one way is you could reduce both fractions, and you would go down as far as you possibly can, and then if the two fractions are equal to each other at the end, we would say yes, those two ratios make a proportion. Okay? So if we had 2/5, is that equal to 16 over 40? So you're basically going to say,
Yes.
are those equal? Well, I'm going to reduce. What could I take out of both of those?
8.
So then we would have got 2/5 equals 2/5. If they're equal to each other, we just simply say yes. Okay? So that's one way of doing it. The second way that I could do this is to use the cross products. Now, we kind of talked about cross products before, or I think Landon actually said cross products the other day when we were reviewing for multiplying by fractions. Because if you multiply by fractions, what's the first thing we should do before we actually multiply? We can try to reduce. In what directions can I reduce? Diagonal. And that's what Landon kind of called the cross products yesterday. So I should have stopped him right there and said it's not, when you're multiplying and you got a dot in between, you can't really say the word cross products. Cross products only really occurs when there's an equal sign. So when you're doing the cross products, you're going to come back to your original problem and you're going to multiply the diagonals together. So a lot of times I like to do it this way. So I'm going to multiply those things together, and I'm going to multiply those two things together, and I'm going to set them equal to each other. And then if that's true then, so if we show that AD is equal to BC, if when we do the products, they are equal to each other, then we can also say yes, as we did over here. Yes. Okay, so there's just the exact same thing, it's just two versions of it. So whatever way that you think is easier. Why we want to introduce both of them is because in some of the problems you might have decimals, and if you have decimals, it might not be that easy to look at it and reduce them. And so instead of reducing decimal numbers, we have a different version of it, and that is doing the cross products. That makes sense to everybody? Okay, so let's try another one. Do 2/3 and 12 over 20. Do those two fractions or ratios make a proportion? No. No. I can't simplify diagonally in this one. So that's a great question. The only time that I can simplify diagonally is if I'm multiplying. Okay, so either reduce this and compare them or do your cross products. So can I reduce this?
Yeah.
What can I reduce this one to? Okay, keep going. So we get 3/5. Are those two equal? No. So they're not equal. So do these form a proportion? We would say no. So let's multiply. What's 20 times 2? 40. Is that equal to 3 times 12? Which is 36.
Oh, well, that's gotta be easy.
Right. So you can do it either way. You can try to reduce them or you can just do the multiplication. So especially if you can use a calculator, doing the multiplication is probably way easier. Okay? So, try this one right here. If you got a calculator, use your calculator. Otherwise, you got to use your melon. So, cross products. Again, this way. Those two together, are they equal to these two together? That's what we're asking. So punch those into your calculator. What'd you get?
6.3 equal.
6.1.
4.
6.4 is equal to 6.4? So we would say yes.
Wait, how'd you get 6.4?
Just multiply. See my purple diagonal? Take 0.8 times 8.
Oh, it's a point, I thought that was an
Yeah.
Yeah, sorry. So there's a decimal there. Okay? And then you're just doing it the other way. All right? Sorry. Yeah, that decimal kind of caught up with my purple.
How'd you get 6.4? 8 times 8 is not that.
Okay? Questions there? So the first part, they're just going to ask you if there are. The second part, they're going to say solve the proportion. So to solve the proportion, we're going back to this format, but one of those 4 spots is going to be a variable. The rest of them are going to have numbers. So do you remember this? Number 1, I can use cross products to do this. So let me get a problem. A over 36 is equal to 9 over 15. So if I have a calculator and I'm able to use a calculator, I'm probably like Ashton said, I'm just going to punch it into my calculator and not worry about it. Okay, so, but we're still thinking about the cross product, so we're still going to do that diagonal and set it equal to this diagonal right here. So basically, I'm going to take 15 times A, which is obviously just putting them together, and then I'm going to do this product, which is 36 times 9. Okay? So now I would punch that into my calculator, and Kenzie's going to get what? 324 is equal to 15A. How would I get A all by itself?
Subtract by 3. Add.
Divide, because this is multiplication, right? So I'm going to divide both sides by 15, and again, remember how we always said we don't really want to use decimals? This is a chance where you can just punch it into your calculator and use that decimal. So if you punch this fraction into your calculator, you get
21.6.
21.6. And that's my answer. So if I were to put 21.6 in this problem right here, those two fractions reduced would have been the exact same thing. Okay? Now, let's just say, for instance, that when we take the ISASP test coming up, next, after Christmas, whatever they're called. Yeah, the new version of the Iowa assessments. It's ISASP, so it's ISASP. But anyway, let's just say that in one of those situations, they say you can't use the calculator on the math section. I think there actually is one little section that you actually have to do the computation. Okay? When you come back to this original problem right here, then you would have to just do 36 times 9 divided by 15, right? So basically what I'm saying here is, if you wanted to just write it down like this all the time, or you can think about, I'm going to look at the diagonal that has the numbers, I'm going to multiply those numbers together, and then I'm going to divide by that third number. So that's another way of thinking of it. But if I actually had to do the math, don't forget that you can reduce first. But when we reduce, the only time that we can, or the only way that we can reduce in these is up and down. So I'm looking at each individual fraction and asking myself, well, obviously here I can't reduce because one's a letter and one's a number. Over here, though, can I take something out of both of those numbers?
3.
Yeah, I can take 3 and I get what? 3/5. And then my numbers that I would try to multiply and divide would just be smaller. But you can always do that. Okay, so if you can't use your calculator, I would probably try to do that, because then the numbers are just going to be smaller. That makes sense?
Then you still cross multiply that?
And then you're still going to do the exact same thing that we did. So now I'm still going to do this.
Okay.
and this. So I'm gonna multiply these numbers and then divide by that one. Okay? So let's try now. So obviously now it doesn't have to be in the same spot. So meaning we can have our variable in any spot that we have in our proportion. So now my v is on the bottom, which no big deal. We're gonna do it the exact same way. Okay, so now take these two, you're gonna multiply those together, and then you're gonna divide by 4.8. So stick it in your calculator. 16 times 1.5 divided by 4.8, and you got what?
5.
B equals 5. Okay, makes sense? Now here, before you go on though, the next thing that you want to look at is this. If I put my 5 back in there, I want to go back and look at each individual fraction. Does this fraction have the smaller number in the same spot that this fraction did? If I put 5 in there, see how the bigger number was on top and the smaller number was on the bottom? It has to be that same way in both fractions. So for instance, if I would have somehow got v equals 22, I automatically can look at it and say, I had to do something wrong because the bottom number should be smaller than the top. That makes sense? Okay? Any questions on there? You want to do another one of that kind? Or are we good? All right, so here's the difference kind. A plus 2 all over 12 equals 4 over 7. So the difference with this problem is what? Yeah, the variable has something with it. So we would call this a quantity instead of just the variable. So what we're going to do is the exact same process though. I'm still going to look at that diagonal and multiply them together. And then my other diagonal, and I'm going to multiply those together. Well, the blue diagonal would still be really easy, right? 12 times 4 is 48. So we're going to say it's equal to 48. But now we got to figure out the purple one. So when you do the purple one, you're going to take this number and multiply it to that whole quantity. So essentially, I'm going to do what? Distribute, right? Because we're going to put parentheses around the quantity, and I'm going to take 7 times that whole thing. So when I distribute, what do I get? 7a plus 14 equals 48. And now I'm back to a two-step equation that we talked about yesterday in the review, right? Cover up that a portion. How do I get rid of plus 14? Subtract 14 from both sides. And we get what? 34. And then a equals 34 sevenths, or you punch it in your calculator and you get 4.8. Then just read the directions to see if they tell you where to route to or how to route to. Okay? This is the other thing I forgot to say at the beginning of the class. Some of you are not writing any work down on your paper. Okay? I know you're using a calculator, that's fine. But like this right here, you need to show me how to set it up, or even in this problem right here, you need to show me what you're punching into your calculator. So it doesn't look like you're just copying your homework down. Okay? Questions here? I want you to try one of these by yourself. So, 10 over 13 equals x minus 2 all over, I believe it's 3. Yep, try that one out. See if you can do it all by yourself. Show your work. How do we do? 4.3? Again, you'd have to look to see what they told you to round to. What's this little thing mean right here?
Or equal, or.
What's a squiggly equal sign mean?
Oh, around,
Yeah, okay. This means approximately, or yeah, around, yeah. Okay, so a lot of times if they ask you to round, or you're kind of guessing at the answer, you use that squiggly one. Now, you can't just use that squiggly one whenever you want and say, well, it's kind of around there. You know, that's not the around I'm talking about, right? Because I know some of you might really think about trying. Okay, questions here? Make sense? We needed to go over that section because it will be on the test. When's your test?